Alright guys, so up until this point we've done a lot with fractions, and now we are going to look at comparing fractions once again. Now if you remember back to my previous lesson when we talked about fractions having the same denominator, then that meant the larger the numerator, the bigger the fraction. If fractions had the same numerator but different denominator, then the bigger the denominator, the smaller the fraction. And those two ways are really easy to compare fractions. So now, in this lesson though, we're going to look at what we do when both the numerator and the denominator are different. What are some strategies we can use? And really, you want to take a look at using benchmark fractions and also number lines to help you, as well as drawing pictures like I told you in previous lessons. But today we're just going to focus on benchmark fractions and number lines and how they both work together to help us compare fractions that do not look at all the same, like the ones we have here. So I'm going to take you through the step by step on what to do. And you can see here we have two fractions and we want to know which one's bigger. There's 2/3 and there's 3/5. What I like to do is I like to use, and you can do this on, if it's a test, you can use scrap paper, whatever you need. You can do this strategy to help you figure out which one's bigger, which one's smaller. If you have fraction strips, you can use those, but we're going to use this number line strategy. So what I like to do is I like to use two number lines because I'm not very good at plotting my fractions, and I can't plot both 2/3 and 3/5 on the same number line. A lot of the lines get confusing, so it's easier just to have two number lines like this. Boom. Now you got to remember they have to be the same size. They both have to line up and match nicely. I can't draw this on a piece of paper and have one way off like this or way back like this, because then the fractions won't line up. And I'll show you what I mean more in a second. So this bottom fraction line, I'm going to plot 2/3. And I'm going to use my benchmark fractions to remember to break this number line up into 3 equal parts, which would be probably like right here, and I'd say right about here. And then I want to label where 2/3 would be. Well, this first line we know right here would be 1/3, and the second line would be 2/3. Just about. It's not perfect. So there's my 2/3. Then on the top fraction line, I'm going to plot where 3/5 would be on the line, and whichever fraction is closer to 1/2 will be the bigger fraction, because it's a bigger piece of the pie, or whatever you want to call it. So now this one's a little tricky, because now I got to break it up into 5 equal spots. This is a lot harder to do, so bear with me. Hopefully I get it pretty right. And that's not perfect, but I think it'll work. There's 1, 2, 3, 4, 5 pieces. So now I go and I find 3/5 like we've been able to do. So 1, 2, 3. Go to the third mark in. This is where 3/5 would be. So now I have a visual aid to look at. I can say, okay, well, which one's closer to the number 1/2? Is it 3/5 here, or is it 2/3? And I think you can really tell that 2/3 is much closer to 1/2. So 2/3 is going to be, let me put my symbol in here, greater than 3/5. Let me show you this on a couple other ones. Here we have 7/8 and 5/6. Once again, I'm going to use two number lines. They're going to be nice and even. They're going to be lined up nice and together. The zeros are lined up, the ones are lined up, so that everything matches correctly. So first I'm going to use 7/8 down here on the bottom, and 8s are easy because I can do a lot of cutting things in half. So if I cut the line in half once, then I cut it in half again, and then I cut it in half again, in between those lines I have 8 equal pieces. 1, 2, 3, 4, 5, 6, 7. So here would be 7/8. It's pretty close to 1 whole, right? I want to make sure we get my circle in there. And 6s are actually pretty easy too, because if I'm cutting a number line into 6, then I can start by cutting it into thirds, which I would say is right about here and maybe here. And then I can just cut in between those lines in half. So cut that in half, cut this in half, and cut this in half there. Okay? And then 5/6, well, I'm actually just going to use the 5/6 out of there because it actually matches up perfectly right on 5/6 here. Now these are pretty close together, but if you really look closely, the 7/8 is actually going to be a little bit in front. If I were to draw like a little imaginary line going up, you can see how it's a little bit ahead, so it's closer to 1. So 7/8 is still going to be greater than 5/6. Now this is why it's important that when you're doing this strategy, your number lines are the same size and they line up. The zeros line up together and the ones line up together. Because let's say you have, let's see if I can do this. Let's say that it's off by a little bit and I were to move it like this and it wasn't quite lined up. Well, looking at this, it would almost look like 5/6 is bigger than 7/8. But that's not true. That's why it's very important that I line all, when I'm doing this strategy, I have the number lines, the zeros and the ones line up. So that way when I break up my number line into the fractional parts that I have, then they will line up correctly like this. Okay? And we're going to go ahead and do one more. We have 4/8 and then we have 2/4. Some of you might already be able to tell me this without us even trying, but let's take a look. So we line up our lines, and remember 8s are easy because I can just find 1/2 and then cut everything in half until I have equal parts. So I cut those in half, and now I cut all these in half, and that would give me 8 equal parts. We've done this before with number lines in class. And again, it's not 100% perfect, but there you go. There's your equal parts. So I find 4/8, which is 1, 2, 3. Here's 4/8 right here. Now, 4ths are easy too, because 4ths I can do the same thing, except I don't have to take it quite as far as the 8ths. I can cut it in half once. Oops. I can cut it in half once, and then I can cut those in half. And then I can label 2/4, which would be right. Here's 1/4, here's 2/4 right here. What do you notice about these fractions? What do you know? They line up, right? That means they're both the same distance from 0 to 1 from each other. They are equal, or what we call equivalent fractions. And we're going to go over more over equivalent fractions in our next lesson, but you guys we've already sort of done this in class and talked about the different equal fractions that there are out there anyways. But in this case, 4/8 is equal to 2/4. I bet you guys can probably tell me what the other equivalent fraction is here. Alright, give it a shot. Tell your parents.